This is a 24 volt starter motor off a 9 litre Cummins HGV engine. You can see it consists of the main starter motor itself. It's also got the plunger mechanism on top and also a little relay there that allows current from the ignition switch to flow into the two coils of the plunger mechanism. The little relay on top is just a solenoid, so a coil of wire around an iron core, and when a small current from the ignition switch passes through that, it basically pushes that plate and makes contact with the two larger current carrying wires. So you can just see there that that solenoid pushes that plate and makes contact with the white wire and allows current to flow to the plunger mechanism. The solenoid plunger mechanism that is on top of the starter motor is just a bigger version of that relay we've just seen, but it has two coil of wires. So current passes through both coils through this red wire at the same time. One has its own earth and the other one travels through the starter motor. Two coils are needed initially to create a stronger magnetic field because of the extra force required to lever the shaft of the starter motor and its pinion gear into the flywheel. So you can just see the plunger mechanism on the end there, and when the solenoid is energized and current passes through those two coils, it pulls that plunger back. Quite a lot of force is needed there to push it back, and you can see it pulls the lever inside there, which in turn pushes out the pinion gear from the starter motor. So we're just going to have a look at the solenoid now. So initially both coils are energized because a larger force is needed to pull the plunger back. So current flows through the relay, through that red wire, to both coils at the same time. So one is called the holding coil, which has its own earth connection at the back of the starter motor and is wired in parallel. The other is the pulling coil and is wired in series and grounded through the starter motor and becomes de-energized and shorted as soon as the plunger is pulled fully backwards, and in effect acts like a relay, allowing a larger current to flow through to the starter motor. So inside then you can see as the plunger moves backwards, it will push a plate onto the two terminals at the back. One is the main battery positive terminal and the other is the thick cable that runs to the starter motor. In the other side of the solenoid you can see the spring-loaded plunger, and so when that is de-energized, that spring will push the plunger back and lever the pinion away from the flywheel. Now to turn the flywheel and turn the engine over requires a lot of power due to the compression of air in the cylinders. So leverage is used, and that leverage comes in the form of a planetary gear system. On the other side we have the starter motor itself, which consists of a rotating armature, which are copper windings which when energized create a magnetic field which then attract and repel the field windings which surround it, which are wired in series with the armature. So on the back of the armature there is a bearing, and that just sits in the housing of the starter motor there, which allows that to spin. So current initially flows through the outer field windings, which are wired in series with the armature. It then flows through two of the brushes and two of the commutator segments around the field windings, back out through the other two commutator segments and brushes, and then back out through the negative terminal. So I just wanted you to see that the current initially flows through that outer field winding and is connected to two of the brushes there, the two positive brushes, but is not connected to the other two brushes. That has to travel through the armature windings first. And then the negative brush there is connected to the negative terminal. On the sun gear of the planetary gear system, which is attached to the armature, there are 14 teeth. On the ring gear that is held in place, there are a total of 46 teeth. Now, the formula for working out the gear ratio of a planetary gear, if the ring gear is held in place, is dividing the number of ring gear teeth by the sun gear teeth plus 1, and that should give us the gear ratio. So that means for every turn of the pinion gear and the planetary carrier which it's attached to, the input sun gear will turn 4.29 times, so the torque that the starter motor produces will be multiplied by 4.29 times when turning the flywheel. So we'll just test that out now. We're just marking the top of the pinion gear, and we'll mark the top of the armature which turns the input sun gear, and we'll see if that does turn 4.29 times to 1. So that's once, 2 times, 3 times, 4, and then we've just got 0.29 of a turn, and you can see that pinion gear has gone to the top again. And if we just go around the other side, we should see that it's gone 0.29, nearly quarter, or just over a quarter of the way around. So we'll just go back to the other side now and take those planetary gears out from the carrier. And then we can remove the pinion gear and the planetary gear from the housing. And on the end of that we've got an overrun clutch, and you can just see the lever mechanism there that the solenoid pulls back on to move the pinion gear into the flywheel. So the overrun clutch on the end allows the starter motor to transfer torque to the pinion gear and flywheel, but not the other way around. So when the engine starts up and the flywheel turns faster than the starter motor, the power is not transferred the other way around, and the flywheel turns the starter motor faster than it was designed to do so, and damage it. So this is the wedge ramp or inclined roller design. So as you turn the shaft one way, the cylindrical rollers will move down an inclined ramp, so there's more space between the outer and inner race, and so no torque will be transferred. But when you turn it the other way, the cylindrical rollers will move up the inclined ramp and wedge the inner and outer sections together. So you can see the cylindrical rollers are pushed against the spring there, and as they move down, they will move down that ramp, and you can see it's just on the edge of that circle. And as you turn it the other way, the way it's meant to turn, it will move up the ramp, and it's just over that circle. So that is what then wedges the two pieces together. And then when it turns the other way, obviously space is created in between the two. Thanks for watching.